Hello, everyone. Welcome to our lightning talks. My name is Marta Skrzypek. I work for DataArt as our fellow speakers. And I would like to say good evening to everyone. We are very happy you decided to join us. As it is described, we have 4 amazing speakers today, 15 minutes for each presentation, maybe a little bit more. We will see how it goes. I just want to remind you that you may ask questions in the YouTube chat during the speech, and our guests will answer them after each presentation. So I am closing my mouth, and I would like to say hello to our first speaker, Jakub Kociubiński. So hello, Jakub. Now it is your turn to speak.
Hi, hello. My name is Jakub Kociubiński. I would like to welcome everyone and thank you all for taking the time to attend this talk. So I'm a team leader and senior Java developer in DataArt, and today I will talk to you about SRE. Let's get this going. Right. So what is this talk about? In this talk, I will try to relate to you the basic concepts of SRE. So there have been whole books written about it, and here I will just try to help you place SRE on the buzzword map of IT and show you just the basic concepts that are connected to it and then that it defines. So to better understand SRE, I think it's best to understand the problems that it solves, because SRE was conceived as an answer to some problems that people had and that people in IT are still having. So a good way to understand what something is through analogy. And so most people in IT understand what Scrum and Agile is, and this is why I think a good shortcut to understand SRE is to say that SRE implements DevOps as Scrum implements Agile. So for those of you who don't know what Agile, Scrum, or DevOps is, don't worry, I will expand on them a bit later on. But for now, let's move forward. So you could also say that actually Scrum, Agile, DevOps, SRE are trying to answer the same very broad question, which is how best to develop software. This is a question that started being asked when people actually were just starting out writing software for others and not only for themselves. This is when everyone started wondering, hey, what is the best approach to doing it? And so the first try at answering this very broad question was waterfall. This is quite funny, actually, because the author of the original paper on waterfall, when he was presenting what he thought about developing software and what the best way to do it is, said actually not to do it. He said, please don't do this. It's not a very good idea. Unfortunately, in the room where he was presenting his work, there were some army generals, and they love hierarchy and separation of concerns and all of that. And they thought, oh, that looks promising, and just started doing exactly this. So the question becomes, is waterfall the right answer to the previous question? How best to develop software? It is not, as a big part of the IT industry discovered the hard way. It's not that it never works, it just doesn't work for most cases. So the second try that we had was Agile. So I assume that most of you are already familiar with Agile as a concept, but just a quick recap. Agile was first popularized by the Agile Manifesto, which consists of 4 values and 12 principles. So the main values are individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. From those 4 values, then come 12 principles. I won't quote them here, but an example is that working software is the primary measure of progress principle. All of those are pretty vague when you really think about it, and leave a lot to interpretation. So two organizations can be both doing Agile and implement it totally differently. Actually, 2 teams in one organization can be doing Agile and implement it totally differently. So this leads to the problem that when an organization says, okay, we've been doing waterfall for a long time, now we want to start with Agile, it's very hard for them to start. So this is where Scrum comes in. Scrum is an implementation of Agile. It gives very specific advice on the previous principles and values, on how to define roles in your organization or in your team, how to develop artifacts, how to structure meetings, and all of those good things. So then the question becomes, is Agile / Scrum the solution? Yeah, it's better. It's better, but we still have a lot of problems, and we still have a lot of unanswered questions. And so the next question that comes after we start doing Agile and start doing better with developing software is what is a good way to reliably produce working code with features that the users actually need. So this is what Agile / Scrum answers. What is a good way to reliably produce working code with features that the users actually need? This is what Scrum answers, what Agile answers. But it does not have any opinion about reliability. So how do we build reliable software? How do we build reliable services, and how do we maintain them properly? So here comes also another problem that arises from this lack of from Agile and Scrum not addressing those questions at all about maintenance, about making reliable services. So we then come to a question of, okay, now we have an organization and we need to maintain those systems. We need to make them reliable. Who is responsible for that? And as in many cases, when the IT and this industry meets a new problem, they try solutions from other disciplines, especially engineering disciplines in other domains. So waterfall is used very heavily in the construction industry. This is where or in the army, this is where it came from. And so the classical engineering answer to this problem is, let's have development and operation teams that are totally separate. And so we have people that are making the thing, making the product that works, and we have people that make it run and take care of it. Now this is you can see the old approach. I think many of us know it firsthand. But the problem here is that what we come to is that we have developers that create a new version of software, throw it over the fence, and then just don't care and say, hey, we did our job, now you do yours, make it work. And now if something goes wrong, we start the blame game. The operation people start blaming the developers and vice versa. So this separation, this very, very clear separation of concerns and of responsibilities may work in other areas, but in software, we've already learned the hard way that the best way to develop software is actually to do a lot of very quick iterations that are feedback oriented, and to add very minimum amount of features and see how it goes. So this is the preferable solution. So here comes in DevOps to try to answer this question or try to solve this problem. Now DevOps is what So there is no one definition of DevOps. It's so developers always want more agility. They want to push their features faster, and operations want to keep things stable. Now, to balance that out, we need cooperation between the two groups. So DevOps doesn't have a manifesto. It doesn't have one set of principles or values. It's very broad. No one ever came together and defined those for us. And so we have a set of practices combining development and IT operations, and this is what we call DevOps. But as with Agile, two organizations and two teams can implement DevOps completely different. So the main areas that DevOps talks about and is concerned about is reducing organization silos. Because we don't want to create separate groups that have different cultures, tools, practices, because this will end in groups not cooperating, not working together to deliver something, but being opposite of each other and result in that what we've seen in the previous picture with just one group throwing stuff over the fence and then blaming the other group if something goes wrong. Accept failure as normal. We need to start learning from our mistakes and stop blaming each other, as we said. So we have to accept failure, understand it's part of the process, and try best to live with it and mitigate it. Implement gradual change, because we need to start introducing small but frequent changes into the system. Experience has taught us that big bang deployments are a bad idea most of the time. Then leverage tooling and automation. We need to approach ops and development. We need to approach operations with the development mindset. Automate all the things. We don't need to do everything manually, and we actually need to be constantly making things run automatically more and more. So making more things run automatically. And measure everything. So we need to start measuring what we can, so that our decisions are based on data, not on gut feelings. And here comes in SRE. As I said before, actually two organizations, two teams can implement DevOps totally different, as with Agile. So now the solution to that problem is, okay, so we need something prescriptive, something, we need a set of practices that tells us exactly how to start, especially for the organizations and teams that never have done this before and just need somewhere to start, and then they can develop their own processes and tools. So service reliability engineering is an implementation of DevOps. It was created by Google, and it gives very specific advice on the roles, artifacts, meetings that we need to set up to make this work. Google at first kept it as their secret sauce to their running services, but after selling their cloud services for a while, they realized that they need to spread the knowledge, because spread the knowledge to their consumers, because if they don't, it's very hard for their customers to communicate with them about reliability problems, and it makes the customers make a lot of false assumptions about how their platform works. So the guiding principles of SRE are: first, reliability. So let's go through one by one on those. So SRE has three main principles. The first one being reliability is the most important feature of any system. Now, if people cannot use your system, if it's not reliable, then it really doesn't matter what it does, right? Because if your users cannot use your system, it can be the best system in the world. It doesn't matter. It can have the best features. On the other hand, it doesn't mean that the system should never fail, because it's a very costly and in most cases unreachable target to set, that the system should never fail. A more realistic goal is that the system should meet the expectations of its users and strive to maintain their trust. Most people are used to and will happily put up with a small amount of system failures, but a lot of outages and problems can quickly cause you bad reputation and make customers leave. The second one of the SRE principles is that users not monitoring decides reliability. So the system must, if the system must show that it's meeting the expectations of the user's reliability, then you have to measure it. You have to measure the experience of the users, of the reliability, of the system's reliability. So if your users perceive your system as unreliable, then it's not meeting its expectations. It doesn't matter then what the metrics say or the logs say or anything else. So if your metrics are not measuring the reliability, what the customers are perceiving as the reliability of your system, then it really doesn't matter. So imagine your support team trying to tell the user that their problem doesn't exist because the data didn't detect anything. That won't go well, I assure you. So this is why the monitoring does not decide reliability, but the users do. And the third one is constant pursuit of better reliability. So you are always trying to get more nines into your the reliability of your system. The first very important principle or very important concept of SRE are SLOs. So those are server level objectives. So as I've said before, taking reliability to extremes is really unproductive. What I mean by that is that we could build a super reliable system that has no features and never fails, but this is really not the goal. Most businesses don't want that. Most businesses need to add new features and are always adding new features. So we need to find a balance between new features and reliability. To control that balance, targets need to be set, and those are our SLOs. So this is the dividing line between a happy user and an unhappy user. Those SLOs need to be agreed on by everyone, so that we don't have different groups having different metrics for what a good system is or a good service is. So we need to take business, development, operations, and everyone else and agree on the target that we are setting. An example for an SLO is site availability of 99.95%, for example. Also, just to throw in, SLAs are not your SLOs. So SLA is a promise about the service that if you break, if it's broken, it means financial fines, probably. So an SLO should always be higher than an SLA. So we talked about SLOs, and that's great. We now know what it means for what a service level objective is, and that's great. But now we need to know how to measure it. So to measure that and to know if the SLOs are met, if a site is reliable 99.95% of the time, we need to have some indicators that show us where the system is at right now. So SLI, service level indicators, are basically the user happiness in metric form, as is stated here. It has to have a very predictable reliability with user happiness. So it cannot be CPU utilization, memory, network utilization, and that do not have any correlation with the happiness of the user. And it should be also aggregated over a longer period of time. It's not about saying that right now the site is unavailable. It's about how much of the time it's been unreliable in the last month, for example. So here we have. So here we see that on the scale we have an SLI that is showing, and an SLO is somewhere in that SLI. So because an indicator can be telling us available, 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 not available, and then available again. And this is what constitutes a happy user and what does not constitute a happy user. An SLI is usually expressed as good events by valid events times 100%. This helps us make it a more more understandable metric. An example for all of this is if we have a site availability of 99.95%, we can have an SLI that just does an HTTP GET to our service and tells us, is it 200? Is it 200? If it's not, then it's not available. And the question is, when we go back, how many 200s over all of the events we have times 100%? And that can be a good SLI. Now, SLI also should correlate very well with the happiness of the customers. So on the left side, we see a bad SLI because it's all over the place, and we don't really know if the SLI is here or there, if the customer is happy or not. On the right side, we have a good SLI that maybe doesn't show everything that the left one does, but it correlates much better with the happiness of the user. Because of that, because of having SLIs and SLOs, we now have a percentage of the time when the service can be unreliable. So this because of that, we have some error budget. We have some time that we can spend on doing other things than having a service that is working fine. So if we say that we want a 99.9% success error rate, then that means we can have 1.0% of failure, and that failure we can then take and we can spend on adding new features, on making the service more reliable, on planned downtime, all of that stuff. So this is, if we look at outage if we look at what it actually means to have 4 nines or 5 nines, if we say that a service is available 90% of the time, that means that per year we are allowed to have 36 days and 12 hours of downtime. If we say that it's supposed to run at 99.999% of the time, then per year we have 5 minutes and 15 seconds of unavailability. So, like I said, SRE implements DevOps, and here we can see the main areas of DevOps, how they are addressed in SRE. So for the reduced organizational silos, if we have the same tooling and shared ownership of code between DevOps, production, and everyone else, or between DevOps and operation, between devs and operations and everyone else, we have SLOs and error budgets for accepting failure as normal. We have gradual change through CI to continuous integration and continuous deployment. We have tooling and automation with automating all of the things and measuring everything by measuring reliability and toil. So that's been my talk. Thank you very much. Now let's see if we have any questions. I've gone a few minutes over my time, but I hope we'll still be able to answer some of the questions. Yep. Okay, Marta, did anyone ask any question?
Yeah, so first, thank you, Jakub. I can imagine that it's not easy to talk about this area in just a short talk.
Yeah.
I cannot see any questions so far. So guys, just please don't be shy. Chat is for you. So whenever some question pops up, you are more than welcome. But since we don't have any questions right now, thank you, Jakub, once again. And I would like to invite our second speaker, Piotr Wieleba, who will show us what BPF tool is and how it works. So Piotr, the stage is yours.
Hello. So I'm Piotr Wieleba. Hello, I guess.
Yes, we can hear you. We just don't see your screen.
Yep. So, hi, I'm Piotr Wieleba. I'm working in DataArt as a senior Java developer. And now I would like to talk about technology that, in contradiction to SLI, has to do something with CPU, memory, and network utilization. And this technology allows us to analyze. So let's start. So I'll try to quickly introduce a few basic terms about system analysis, then with few sentences about BPF, kinds of instrumentation, and I will describe 2 front-end tools that use BPF. Yep. So basic terms. First is tracing. So tracing is possibility to reason about the system with event-based recording. So we start recording of the events, do some stuff, stop recording, and then we can post-process it. Or it is possible that some tracers display statistics that are periodically updated, for example, top or trace. On Solaris system, trace was called Snoop. That's why in some tools that I show later, name trace does not exist, but they rather are called exec Snoop or open Snoop, something like that. Another kind of analyzing is sampling or profiling. This analysis takes into account only part of the system events. So it allows you to show coarse-grained picture of the system. Performance overhead can be lower because of that. We don't need to analyze everything, and samples can be taken once every few milliseconds. So now, what BPF is? BPF actually is a Berkeley packet filter. That was a technology that was invented to filter packets, TCP packets that come to TCP dump. In 2014, Alexei Starovoytov had this brilliant idea that this technology can be turned into general purpose virtual machine that allows you to create advanced performance analysis tools. So nowadays, when we see BPF, it actually means this extended BPF. Nobody, I think, used that BPF from 1992. So how this BPF looks like? So it's similar to Java bytecode or a simple assembly language. It's this very low-level concept designed to be emitted by a higher level tools. So this is example of a BPF, how it looks like. And BPF trace is actually that higher level tool that emits BPF code. This code is efficient. Why do we use BPF? Because it allows us to efficiently analyze production servers. It's built into the kernel, into the Linux kernel. Of course, you need to enable configuration option during kernel build, but now it's like default. Every kernel has its most of the popular distribution has it enabled. So you don't need to add any new modules to the kernel. And BPF works in the way that the code that is emitted either by a high-level tool or written by yourself, it's executed in the kernel space in the Linux. So it is safe because it is first analyzed and verified. And verifier does not allow to run BPF code that will crash the kernel. And now let's talk about type of instrumentations. We will not cover all of them, but just a few. First is dynamic instrumentation. So it's the ability to instrument live software. It costs zero overhead when not in use. It's somehow similar to adding breakpoint to the code. When enabled, it instruments beginning of the function or return of the function, all return points from the function. When we enable the dynamic instrumentation, we actually insert int3 assembly instruction into the address of the function, or in some cases, jump instruction is used. For dynamic instrumentation, we can instrument, for example, kernel functions. And for this, we can use kprobes. Kprobes can instrument every function in the kernel. Along kprobe exists also kretprobe that allows us to instrument return from the function, and combination of both allows us to calculate duration, how long it takes to run a kernel function. And to use it with high-level tool BPF trace, we use either name kprobe or simple just letter K. And with this instruction, we can list all kprobes that are available in the system. I've checked it today, it was over 60,000. And for the user space, there is also a kind of dynamic instrumentation that are uprobes. So this concept runs in the user space, not in the kernel space. And as kretprobe, there is a uretprobe for instrumenting user code. By user code, I mean, for example, library. So it can be enabled or used in BPF trace, but just typing uprobe or just shortcut u. So with this code, we can check how many uprobes are available in libc library. I've checked this just before and was about 4,000, over 4,700 uprobes available in libc. Second kind of instrumentation is static instrumentation. So there are some downsides of dynamic instrumentation. For example, name of the function can change from version to version, or compiler can inline function, so it will be unviable. Static instrumentation rely on event name, not on function name. It adds some burdens to maintenance because number of these event names can be high at some point, and we need to have backward compatibility. In static instrumentation, for static instrumentation of kernel function, we use trace points. And for static instrumentation of user space, we use something which is called user level statically defined tracing, which we will not cover in this talk. So maybe one more thing about trace points. Trace points will always add a very, very little overhead when not in use, because there will be part of code that will emit a trace in this case. So kprobes are better in case of performance where not in use. So let's analyze two tools that use BPF under the hood. So first one is BCC, which stands for BPF Compiler Collection. It's a tool that allows us to write the BPF kernel in C-like code and use it in either Python or C++ or other languages. Most of the code I've seen written in BCC was in Python code. So actually the kernel, BPF kernel, is in Python string and then just put into the BPF function. So this C-like code, actually, I don't think it's needed to write it, because when you install BCC, there are already loads of tools that are ready to use. You don't need to build them at all. For example, there is OpenSnoop that trace every single process that opens a file and get host latency, will help you with analyzing DNS latency. Biotop will show block input-output operations, TCP for networking, exec-snoop for every call that has something to do with syscall exec or execat or exec-kind family. So actually, I've checked that in my installation location, there are over 120 small tools that are ready to use. So this picture I've taken from GitHub BPCC home site. So we can see here that there are tools for nearly every single aspect of the Linux system that can be used. Later I will show you for one of them, like for example, exec-snoop. A part of BCC, there is also BPF trace tool that you've seen before in a few slides. So this is a new front-end tool. It provides Oak-like language to write very specific tools that are called one-liners. It is even possible to write small scripts if the one-liner will be too big. So this is an example of one-liner that used tracepoint, and this code will actually show us every single sysenter open execution along with process ID, the command, and the argument that is passed to the command. So let's take a look at how it looks like. Yep. I will not retype this. Just show it. So we hear that there is big amount of entries here. So we would like to rather put it into a file somewhere. Most of them are repeated. So let's go to second example. This one we'll analyze the same syscall, so opening a file, but here we will not print every single line, but rather count them and show summary after the execution. Yeah. Let's increase this a bit. There is one restriction that BP F code need to be run from the root level because it's executed in the kernel space. There are some works to allow execute this from execute this without root, yeah, but it's not. Oh, sorry. It's not possible now. So let's stop now and see what's going on. So here we see that here we see the summary that show us command, parameter to the command, and number of executions. So just one line and gives us coarse grain looks of the system, how system works in terms of opening files. So this one-liner will show us entries or commands that execute something. So it will use syscall sys_enter_exec. I will show two kinds of this this code. One is exec snoop from BCC tools. Let's show it now. And the second one will use BPF. Those are not similar. Those are not the same, but are similar. Yep, so we see that something is going on. I will open next terminal just to execute some code. And for example, we see that when I open new terminal, git command is executed, along with some PowerShell, PowerLine shell, and different ones. Yep. So let's stop this. And here is a similar one. It will not look completely the same because I will not print parent ID, but only ID, process ID. So let's do it once again. Open shell and close it. So this is similar code in BPF trace. And just okay, information about BCC can be found in the GitHub homepage. And there is a great book by Brendan Gregg about Linux system and application observability, which is called BPF Performance Tool. And he is the guy that works at Netflix. He's performance engineer at Netflix. And in these books, there are examples how they use BPF to increase performance of Netflix servers and services. Thank you. That's all I have. I think I fit into 15 minutes.
Yes, that's right. Thank you, Piotr. Thank you for sharing your experience with our audience. I don't see any questions, unfortunately. It seems that all your presentation are super clear, basically. So thank you, Piotr. And now we are moving to Witold. So Witek has a kind of an eco-technical topic, or maybe I'm wrong. I don't know. Let's see. So Witek, the stage is yours.
Hello, can you see me?
No, not yet.
Okay.
Oh yeah, now we can see you.
Give it a second. Okay.
Yeah, sure.
Okay. Can you see the slides?
Yeah, it's perfect. You can
That's
start.
perfect. So, hello everyone. My name is Witold Kaczurba. I've been with DataArt nearly 2 years now, and it's great to have you here, listening to our talks today. Today, I decided to talk, provide a very kind of like high-level talk about code reuse and engineering reuse in general. This talk will be primarily based on my experience with different projects, and I'll try to raise awareness about certain aspects that people should be just generally aware when they code and when they develop any next projects. So what I'm going to talk today really is talking about the bricks and talk about people. Really, this is all that matters in a project. What I found is that when you move from one project to another project, particularly within the same organization, there is a lot of code and there is a lot of engineering work that was already put in place and can be reused, right? And these are actually bricks. People sometimes they're not really considering, you know, that the reuse when they join the project, and they don't really foresee the fact that in a matter of a year or 2 years or maybe 3 years there'll be another project. And these are the items I'd like to really focus on today's talk. So why is it important? Why is it important to see the next project that is around the corner? And why is it important to make your code or projects more reusable? And I think just we need to really ask ourselves the question: why is it important at all? So basically, the world is changing, the businesses are changing, and at a very high level, if we work for any organization, there'll be changes happening to our business. They might be caused by fact, you know, that there are some external factors. There might be some roadmaps changed to our product. We might be trying to target, you know, different mobile platform. We might want to try to move our application into software as a service domain. We may need to change technology to technology because of various factors. And because of all of those things, we often actually end up having a next product or next spin-off, something that is relatively similar to what we've done so far, but in a different configuration. So that basically you can reuse some of the business logic that you had in the past, that you have developed in the past. And you know, if you categorize this among 3 different items, there'll be product roadmap changes, like caused by customer demands, new product spin-offs, technology change or frame obsolescence. This can happen, for example, when you have a project that you developed to a certain stage and you are suddenly pushed to change your framework because of security vulnerabilities or because of the fact that framework will be no longer supported and there is more and more risks involved in using the old platform. And finally, there is also a human factor. You know, if you want to keep things going, you know, with your product as a software manager or as part of management, you have also to be aware that you have to have a right skill set to support this product further and keep the technology in line to what is offered, what people can do in terms of their skill set. So in general, when we move from one project to another project, and in terms of our engineering reuse, our primary goal, just looking purely from a reuse perspective, is trying to reuse as much as our bricks as possible. We need to reuse those elements in order to save our time, in order to reduce costs, to allow expansion of our business, and to address any of the changes, you know, that might happen, you know, in the ecosystem, deal with disruptive innovation and so on. So people generally try to think to themselves, how do we shield ourselves against those changes? How do we adopt to make those changes easier and better? And if there's any silver bullet that can help us, you know, with the better reuse, people work under assumptions, you know, that, you know, to a certain extent that management is responsible for, you know, for us developing software better, that there should be a financial discipline allowing people, you know, to work better, to learn from their mistakes, to share, you know, knowledge better. There should be a proper change management team in place in order to facilitate those changes and prep us for the change that is around the corner. Which is true to a certain extent, obviously. On the development side, we as developers know that the code reuse is an important thing, so we try to push our artifacts to our local repos and reuse them. Apply best coding practices, like do not repeat yourself, keep it stupid simple. You know, you're not going to use it again. You know, different sort of applications, different sort of principles, like solid principles and so on. With selection of right frameworks, dependency injection, multi-module design, separation concerns, have a right proper, you know, appreciation of your personal. and readiness for any product or any product handover. So if we have a project, we can hand it over to the next team, so we can focus better on our next project. And we have all of those things in places, and suddenly we end up coming to the conclusion, that this is actually something wrong. You did all of this, right? You've got fab management, you get fab developers, everything's working fine, but now you are moving your service to microservices, and there is a big glitch. There's something wrong. This is something that you have not really anticipated, in the first place, and you suddenly start seeing complexity that you haven't seen or anticipated in advance. And I came actually to the conclusion that it happens on really many projects, that people don't really see that this thing happening, that they will come to the next project and they will have to reuse it. And I came to the point, that people, on the project don't really question the projects, enough. They don't critically think about it, about patterns at any sort of levels, from developers to team leads to software managers. All of them are responsible to asking themselves, can this project be reused, and to what extent? If there is a next iteration and there is a next spin-off, how long? What would be the effort of rewriting an application? And given the fact, that you have already put some work into it, for a different platform, for different languages, for different environment. So this is a very basic question that people need to ask themselves on a regular basis. What is the cost of an app or component rewrite, given the effort that you already put into the project? If you are to target a different platform, if you are to use different database, whether you have abstracted yourself from it, if you need to use different architecture, underlying framework, and so on. And that's not the end of it. The end of it is really testing. And what I'm trying to emphasize here on this slide particularly is that even if you reconfigure, even if you reuse your code base to maximum extent, it has to be testable. And the test, and having integrated tested with a new setup is an ultimate key, and it's an ultimate, figure of measure telling you whether it's going to work or not. So as I said, need to try to keep things simple, because this is the most important thing, and question yourself on a regular basis. I put a couple of slides from different projects and from different experiences, trying to highlight, what's really the importance of engineering reuse. As I said, I'm trying to keep it very high level because I'm assuming there might be some managers, developers, and might be some people, who are related closely to business. So let's get started with some examples. When you look at electronics, I hope that there's going to be some fans of Arduino or Raspberry Pis. When you look at electronics, what happened in the last 10, maybe 15 years, you will see that there is a very strong push for modularization. The modules come in all possible sorts of shapes and colors. They are easily interchangeable. Once you get your Raspberry Pi, you can get any type of a sensor, you can test it, you can run it. You have standardized interfaces, you have software libs out of the box. And finally, once your POC is proven to work, you can copy-paste designs from your PCB to schematics. You can virtually copy everything and get the start up and running. And this was very strong push for any of companies who deal with sensors and so on. Another interesting example of engineering reuse that I really want to explicitly mention here is silicon reuse across semiconductor companies. I used to work for one of semiconductor companies, and very common practice for many years is to keep your IPs ready for development of a new product. If you look at companies like Intel, NVIDIA, or Qualcomm, they all actually use IPs so that they can put it together, an SoC or your CPU, and create a new spin-off out of it. The challenge there, however, is with testing of the glue, right? Whatever they interconnect with it, it has to be tested. And this is what I already mentioned a couple of slides earlier, that the testing of the glue logic is fundamental. And this is exactly what your integration tests are in the new setup. So this testing of the glue logic tells you how much effort it is. And in terms of semiconductor companies, this is massive. Testing is massive, and therefore they have appropriate tools for that. They keep developing, and in the last couple of years, there's been a lot of development in this regards to this. My own experience of moving monoliths to microservices is that when I joined the project, it was a couple of years ago now, everything looked kind of like fine. You had your dependency injection, you had abstraction of the databases, and so on. And you would expect, that moving a web app into microservices should require some level of effort, but it shouldn't be really a sort of like a very massive, great deal. What really had happened was we started reworking the whole application was that there was obviously dependency injection, but it was not really well thought in advance. There was AOP missing. A lot of stuff or a lot of beans were interrelated to each other. And if you were pulling a service, you had loads of stuff, security services, loggers, network loggers, and so on connected to it. Things that should be really completely abstracted, Another thing, that was really interesting to me, that I found really challenging was the fact that certain features of an application that was not really substantial to business, that was not essential to business, could substantially affect your application by the fact that essential components relied on those non-essential things like reporting. And when you try to pull things together, pull things apart, you're reporting from a module that was responsible for your customers or your clients. You had to put a lot of code. You had to remove loads of lines of code for things that should be really completely separate. And seemingly everything went through, code reviews and everything without being challenged. And I had also a similar experience with moving an application from on-premise to cloud services. That architecture that looked relatively okay started to be not that easy to rework because of certain patterns that were happening in between the applications. So the applications, some of the applications tend to exchange data about objects, and there was no single point, where I could ask for entire object. And then you started having some sort of like a weird chatter patterns between them and so on. And I think when you look at all of those kind of events, really, I strongly believe that the bottom line of it is the fact, that people don't really think in advance about code reuse, about the fact that around the corner there will be a next project that they'll have to reuse the stuff from it. In order to safeguard themselves, from sudden discovery of new complexity that they didn't foresee in advance. So just to summarize really all of those things, I think, first of all, that the project-oriented companies that develop, project after project after project, they tend to adopt faster to change and reuse IP better because this is what they do on a regular basis. This saves their costs and also speeds up time to market. In terms of product or servers-based companies who have their software application running and that needs to be upgraded or revised every so often, or that plans a non-regular intervals of upgrades, you need really to be very careful about this and just try to see things and what is happening around the corner. And I really strongly believe that the critical assessment of a project is a key to support overarching greater goals, which is targeting your application to a different market, to a different business model, to make it less vulnerable to any political changes and so on, so that you can get your A project and move it to the B project and reuse it as much as possible with the minimum effort. So back to what I said from the beginning, the bottom line is first, user imagination, second, user critical thinking, Can you pull things apart in your project? Can you put critical pieces together in a completely new configuration? And lastly, can you test that fast and fast enough? So these are all the items that I wanted to share with you. I hope you enjoyed the presentation. And if you have any questions, just don't hesitate to write it down into the YouTube channel. I'm waiting.
Yeah, actually, so there is one question for you. So the question is, in order to reuse a tool or software, when a project is changing, what type of communication style, direct, vertical, horizontal, a project manager can use?
I think really that in terms when a change is happening, right? It's not only software managers' responsibility to communicate that this is happening, and I think that the software managers team must be informed upfront, that you should expect, that there will be a next thing coming after it, and you should really prep for that already. If you're doing, your coding, and if you are leading the team, being really prepped for that. And it also applies to a software manager in a way that he shouldn't really allow too many different technologies in one place, because when it comes to handover, you might need to change the team. You might need to try to assign it to different people. So when it comes to communication, I really think that generally speaking, the communication should be coming from all possible directions here, and people should be really kept up to date when it comes to new projects, that they should anticipate something when they should anticipate something, and so that they try to be ready for it. But anyways, the good practice is that you should always keep yourself challenged with the project, and always ask yourself the question, how can you reuse the stuff that you have written, particularly when it comes to your core business logic. I hope this answers your question.
Yeah, I see no comments, so I guess everything is clear.
Okay.
So thanks, Vitek. That was a very cool, interesting presentation, I must admit. And thank you once again. And now we turn towards Michał. So Michał will tell us how to create our own educational home lab. So Michał, now the voice belongs to you.
Hi guys. Okay, let me share the screen. Okay. So I'm Michał Urbanowicz, and I'm basically working in DataArt for over 3 years now. I'm doing system administration stuff, so I'm managing some networks, some servers, etc. And today we will have some quick presentation about Home Lab. What can you get on a budget to learn something in the home? Because it is quite problematic if you are a sysadmin or you are working with infrastructure in general. It is quite hard to do it in the work, because usually everything is production environment. Most companies do not have their own laboratories. So what if you want to learn something, or what if you want to learn something and you are not sysadmin at all, so you have no chance to have some contact with hardware? So the first and most important point, in my opinion, is getting used hardware. Why? Older hardware is generally uncomfortable for companies. What sysadmins use in their work is usually some enterprise class hardware, like enterprise servers, enterprise switches. And when they are getting older, they are getting less reliable, and they are becoming a cost, because you need to repair them more often. You need to make some more time for maintenance. So there is plenty of used stuff in the internet. And I think the most significant example is network hardware. It is very, very strange, because here you can see Cisco router, which is quite recent model. When it is new, if you buy it new, it costs about 3,000 zlotys. If you buy it used, it costs 200 zlotys, 3,000 zlotys, yeah, if it is new. So the difference is over 10 times. And the device is the same. The difference is that used device does not have Cisco support. It's usually work for some years in the server room, but that's usually not a problem because server rooms are pretty well cooled. So for electronics, it is perfect environment. Also, here you can see a switch. It is actually quite recent model of HP switch, which costs over 2,500 zlotys new, and on used market you can buy it for 600 zlotys. So also it has no warranty, it has no support. I mean, it does have support in terms of software updates, but it does not have the manufacturer support if you have some problem with it. So sometimes you buy this hardware, and sometimes even you will find a way to update it to latest software. But anyway, it is perfect for education. If you need some router for learning, if you want some Cisco stuff, you don't need to use emulators because real devices, the real thing is so cheap. And I have not selected the cheapest examples from the past. Those are the biddings on Allegro, which are out here right now. You can get even cheaper the cheap network devices of exotic brands, because we know the most frequently used ones. We know the Cisco, we know the HP, maybe Aruba, but also there are several other companies. And what is cool is that there are not much guys knowing about this stuff at all. For example, Brocade switches, they are somewhat similar in terms of command line interface to other manufacturers, but they are not identical. So also they are not so popular. But if you want to learn some technology, you don't want to learn about particular device or configure particular device, you just want to try out some technology, this is one of the best options, because as you can see on the picture included, this is Brocade switch, which has a lot of optical interfaces. It has a lot of gigabit ports, layer 2, layer 3 routing, and all the exotic stuff you might even dream of. It is ridiculously cheap because it is not supported by Brocade anymore. It is given to recycling by companies, and then it is landing on some bidding portals like Allegro, eBay. So yeah, manufacturers like Brocade, Extreme Networks, maybe Aruba can be both a lot cheaper. And when we are ending the part with network devices, this is the most cost-efficient stuff you can even buy. It is BT Home Hub 5A router. It is British Telecom official router, which they are giving away when we are buying some internet connection from them. And it is cool because it does support OpenWRT, so it does support Linux software. So you can transform it from proprietary British Telecom router to open source Linux device. It has a lot of interfaces. It has 2 Wi-Fi radios. It has USB. It has VDSL modem, and you can buy it for 20 zlotys if you buy it on United Kingdom eBay. I usually buy about 5 or 6 of them, and and sell them to my colleagues and combine shipping. So this is really, in terms of price to performance, relationship, and what can you do with this device for its price, it is ridiculous. As for server stuff, you want to try something with servers, you want to try some database servers or something like this, I think Mikrus is the most interesting stuff. It is cheapest VPS on the market in Poland ever. You get it for 35 zlotys per year, not per month, per year. You get support, which is really great. It does not have any official SLA because it is hobbyist stuff. But for its price, you can't really demand anything like this because it is nearly for free. And you have plenty of distribution to choose. Sometimes there are some promotions that you can get it even cheaper, but you need to watch and check the Mikrus Facebook page for those promotions. It is really cool for simple projects that do not require a lot of resources, because As you can see, it has a amount of RAM memory of first Raspberry Pi, but actually the CPU is much faster and you have plenty of disk capacity. So for this price, not bad. This is my second budget devices, my favorite second budget devices when it comes to, like experimenting in home. Thin clients. Thin clients are kind of minimalist computers. They contain usually some older desktop CPU or some low power CPU. They contain small SSD drives. They contain some RAM. The thing with them is that companies replace them very often, because those thin clients are quite cheap compared to personal computers. And manufacturers of those think, okay, let's support it for 3 to 4 years, and then they will buy a new one. So those devices are normally used for connecting to remote desktops. So the employee comes to the office, starts this guy up, and he can connect to his remote desktop. But you can repurpose it to any other application, because it is actually a normal PC, just in some kind of specific case. It is quite small, and but you have all the interfaces, and the most cool thing about this one is that it has very minimal power consumption. Those devices are designed to be very low power, and they consume minimal amount of energy. And here is my favorite one. I'm not like advertising, but I think in terms of price versus performance, this is the best you can get. So Dellwise terminal. It is the most recent model. You can buy it, as you can see, for about 500 zlotys on Allegro. And it has quad-core CPU. It has DDR4 RAM, 4 GB by default, but you can expand it to 16. It has 16 GB of like included flash, but also it has a free M2 slot, so you can expand it if you want. It has some USB ports. It even has USB-C connector if you want it. 2 DisplayPort connectors, so you can connect 2 monitors, and also it has passive cooling, so it is not making any sound at all. And the best thing about it, 6 to 8 watts power consumption. Yes, I have measured it. So you won't feel it on your like electricity bill. And for such energy saving stuff, it is very powerful. So I have one using it as a media center. I have second one using it as a home server. No problem whatsoever. And like another option for home server to home laboratory is HP Enterprise Microserver. Those devices are a bit different than the previous ones, because they are actually a real enterprise servers. So they are not like repurposed device like thin client modified to something other, etc. They are real servers. They have a lot of the features of the big servers, like the hard drive base, etc. Also, they have HP ILO, so we can manage them out of the band. The latest generation have four Ethernet interfaces, so it is very capable stuff. And also they are very silent. If some of you guys experimented with those big, real rack servers, you know that they are crazy loud. And I also went through this. If you try to keep it running at home, it is very, very disturbing device. And those microservers are very silent, so you can keep it running in your home, no problem whatsoever. They are not the cheapest ones, because the current generation, which you can see on the right on the picture, is about 2,500 zlotys for it, but it is very capable device, and I highly recommend it if you have money to spend on it, and if you want to experiment with some heavier stuff like virtual machines, maybe VMware, SXI, etc. And the last and I think very interesting thing is the rack. It is the way to use your old IKEA rack, your old IKEA table as a rack mount, like shelves. So for some reason, the distance between the legs of those tables are exactly the same as the rack devices. So you can use them as some kind of rack shelf, which are usually very expensive. If you want to do this, I highly recommend getting from friends or from family the old table, because the older ones are much more stronger. The latest ones, which you can now buy at IKEA, are much weaker. They have weaker legs and they are not as good. So what I did is I told to my sister if she has some luck, and she gave me the old one. Yeah, so no problem whatsoever. Yeah, so now it is time for some demo, and I will show you what you can serve. What servers can you run on this 20 zlotys open WRT router? So the router is, the standard one. I got it from eBay. I only modified it to run Linux. So it is running OpenWRT Linux distribution. And as you can see, it is running a few servers. So let's see what can be done with it. Okay, let's minimize it. Yep, so I have prepared some shell on this router. And let's take a look, what does it have? So now we are logged into this 20 zlotys router. And as you can see, it is now running Linux. It is running very recent kernel version. But the very important point is that it is running MIPS architecture. It means that executables from usual PC computers are not compatible with this one. You need to compile the software on its own to run on the MIPS architecture CPU. Let's check how much RAM does it have. So as you can see, it does have 128 megabytes of RAM, which does not sound a lot. But remember, I have run a lot of services on this guy, and it is still having some free memory. Yeah, so as you can see, we have all the servers here. Here is HTTP server. Here is the HCP server. Here is Samba, as I have said before. So yeah, it is pretty capable stuff. And actually, for 20 zlotys, it does have a dual core processor. So you have processor 1, and you have processor 2. And as you can see, the machine is BT Home Hub, the British router from British Telecom, which you can buy extremely cheap. Yeah, so we have all these servers running on this device. So let's see what it can do. So I have prepared the virtual machine, and let me make this guy smaller. The virtual machine does not have any, we can even delete it, does not have any hard drives. It doesn't have any, means of booting. I mean, no CD drives, no nothing. So the only capability for it is to boot it from the LAN. Let's see now. Okay. So as you can see, Fatal could not read because it does not have any media to boot from. So what we can do is to boot it from the LAN network, and I'm doing it now. And as you can see, the network card is searching on the SCP server. It is initializing the IPXC, which was loaded from this 20 zlotys router. So what happened now? The LAN firmware got the DHCP address, got the IP address from the HCP. It got the files to boot up from this 20 zlotys router, and it runs some IPXC software. IPXC is actually some kind of bootloader which you can load from network. So you do not need any pen drives, you do not need any hard drives. You can boot IPXC purely from network. And I have prepared 3 examples. And let's start with Windows PE. Windows PE is some kind of minimalistic Windows form. It is, for example, run when you are installing Windows. So when you run Windows installer, you are getting actually a Windows PE instance. So what will happen now? We are running it, and IPXC is loading files of Windows PE from the remote server. And actually, the remote server is this 20 zlotys router. So you can now see that it is running the PXC server, so it booted from the network. And also it is running the HTTP server, which allows it to download Windows files to the virtual machine. And now they are getting loaded to RAM. Let's wait for it. It is not too fast. I will show you the CPU load on this router now. And as you can see, for 30% of sys load, that means that USB bus is loading this router a little bit, but it doesn't matter. It is loading, so maybe a little bit slower, but come on, it is 20 watts device. And as you can see, we still have some free RAM memory. You will maybe ask, what do I use it for? So I use it for the kind of situation when some friend or family is giving me some laptop to repair, to reinstall Windows, but they want to save the files. And I do not want to connect my portable drive, etc., to those computers because they might have some virus or stuff. So I boot them from the network and I copy what I need to the network. Yep, so the Windows P is running. And now, as you can see, the Windows P mounted Samba resource. Also, Samba is running on this 20 watts router and started Total Commander. Everything is running on the router. And now we have drive Z mapped as network resource also on the 20 watts router. So it is all self-contained, no other servers involved. And for example, you can start Windows 10 setup if you want. Yep, as you can see. Or you can start some, other diagnostic tools, or you can copy some files with Total Commander to back up some stuff. Yeah, so that's the first thing which I done, and now it will restart. Sometimes you want to reset some password. You have a computer which you have forgotten password for, and you want to reset it. And usually, System Rescue CD or other Linux distribution with proper tool is used. So let's run it. Let's boot from LAN once more. And as you can see, it is getting the HCP address. It is booting from our router. Okay, we have some problem. It is not the problem with the router itself. It is problem with VirtualBox, which is not fixed for years already. But it does not matter. Now it will work. Boot from the LAN again. Yep, and now let's boot the Linux. So again, we have booted from the router, and now we are also downloading files of Linux distribution from the router via HTTP. As you can see, it is still downloaded from our 20 watts router. Yep, the kernel is started, and it started to download the complete image of System Rescue CD from the router. So as you can see, the speed of the connection is about 5 megabits. 5 megabytes, sorry guys. So it is not a lot, but it is limited first because of pen drive I used for this purpose, because I needed to plug in the pen drive in the router. As you can see, the router itself does not have a lot of space, so we have about 200 something megabytes. So what I needed is to add additional, like pen drive for file storage. And what I have there is just the stuff we are using now. So I have there some image of this Linux stuff. I have there boot files for this Windows P thing. But you can also use any other pen drive. You can use a bigger one. You can use a portable hard drive or any USB connected hard drive and make some network access storage. Yeah, so let's wait for it to load. It is quite slow, but it is not too bad. When you are in need of in some emergency situation, you can wait for some minutes. As you can see, the image is pretty big because it is over 600 megabytes. So it is not too small. Yeah, but the signature is verified. Yep, and now we have the full Linux system, which we have booted from the 20 zlotys router. No other servers involved, no other devices, no other pen drives, no other CDs, either emulated or real. And let's come to the last thing, which I want to show you. Let's boot up from the network again. Again, it's crazy. VirtualBox bug. It is not fixed since several years. It does not happen on the real machine. Yep, and the last thing is mem test. So I have included it just for fun when you need to test some computer in case you suspect the memory problems, RAM memory problems. Yeah, you can also run it. And the RAM will be tested. Yep, as you can see. Yeah, so that's about it when it comes to demo part. And now I will just show you how the IPXC configuration file looks, because maybe it interests you. So actually it does have some config lines for, for console parameters. So what resolution of the menu should it have about menu items itself? And here you can use some commands to get the stuff bootable at all. So that's what I used for System Rescue Linux and MM tests. Just needs some simple mounting of virtual floppy drive. So not much stuff at all. So what I wanted to show you is that it is very extreme, because you have a lot of services running on the device which you can buy for, like 4-pack of beer, and you can make it serve, HTTP server, PXE server, all kind of stuff on such a cheap device, only because you can make it very easy to run Linux. And that's the similar stuff with other devices I've shown, but I think this one is most incredible. So we have British Telecom router, which is thrown away to trash in the UK, and you can buy it for like 20 zlotys. But what can you do with it if you spend some work on it? Yeah, so that's about it, guys. If you have any questions, feel free to ask them.
Yes, Michał. So actually, there are 2 questions for you. First one, what is SLA? Is it related to service level?
Yeah, it is service level agreement, and it is usually presented in like a percentage of availability of particular service or server. So for example, if you are buying some virtual server, some virtual machine, it might have a SLA of 99%. So it should theoretically be available for 99%. The 1% of time it is, it is working, might be some failure. Of course, it is kind of, as the name says, like agreed level. So it is not always the exact case. Some servers have like SLA of 98%, but in reality it's 100%, because they do not have any problems for years. But it is kind of theoretical, but it does have some meaning for serious projects.
Okay, and there is one more. Michał, how many servers did you buy, and do you still have place at home for more stuff?
I have dedicated room for this stuff actually, but when the child will kick in, it will be hard, because wife will kick me out of it. So I have both a lot of servers. I've had rack servers, but they were so crazy loud that I needed to run them for like a few hours when I was experimenting. And but now I have like changed my way to silent servers. So I am using mainly those wise thin clients to have some free computing resources at home.
Okay, great. Thank you.
Thank you very much.
That's it. Thank you, Michał. That was very educational. I hope our audience will make use of it. And guys, once again, big bravo to our speakers, and thank you very much for joining us tonight. If you want to follow our next events, please check all the links below the transmission and follow our Facebook pages. And thank you once again, and have a great evening.